In this tutorial we'll have a look at time warps. In other words, changing the speed of a shot to go faster or slower. In fact, there are two ways of doing this on Mistika, a classic way and an advanced way. The classic way works by simply dropping or duplicating frames or fields, whereas the advanced way uses optical flow technology, which maps every pixel on the frame in order to create subframes to make ultra-smooth slow motions. The two different time warps are accessible as follows. The classic time warp is in fact a function of grouping. So I'll select this clip, press G for group, and under Edit there's an option Time Warp, or the shortcut key is T. Note how the group will change colour from the green that we see now, which is a group, to a time warp. And we can see that the character has slightly changed in that the name of the shot has been appended with a percentage number, which is actually the speed at which the shot is running. Currently, because I haven't changed anything, it's still on 100%. The advanced way of adding a time warp is to select a shot and rather than group, go to FX and under Images select Time Warp. Before we look at this in detail, let's just have a quick look at the similarity between the parameters. As you can see, the classic time warp has some simple parameters here. Note time, and speed. The advanced time warp has more controls, but still has time, and speed. So let's look at these parameters in the context of the classic time warp. When we change this clip to a group and then to a time warp, it fundamentally changed how it will behave on the timeline. For example, if I ungroup, go back to the original clip, we'll remember that if I right-click or equivalent pen button and drag along to the end of the clip and then press my left button at the same time, so I've got two buttons pressed, I effectively start changing the tail of the shot. The same as pressing trim tail down here. This fundamentally changes on a time warp. The same action, in fact, changes the speed of the shot. Notice the percentage is changing. So from slowing down, 72% of the shot speed, to speeding up, 213% of the shot speed. This is actually quite handy, because if you're faced with the challenge of working out how fast that shot has to run to fit inside that gap, you don't have to do any maths. Align the shot into the gap, set it as a time warp, and change it till it fits. That shot will now run at the speed necessary to fit into the hole. Let's look at the parameters we have for the classic time warp. I'm going to double click to go into the visual editor and press curves so we can see the graph. There are two methods of communicating with the time warp to tell it what we want to do. They're actually mutually exclusive, so use one or the other. By default, time has animation in it, so it's the one that's in use. If we were to delete this, then in speed we could simply type in the speed at which we wanted the shot to run. So for example, to run it at 50% speed. Alternatively, the time graph allows us to specify the input frame versus the output frame on a graph. So this allows us to do speed ramps and so on. So if I simply reinsert what would have been there by default, what we can see here is on frame 40 of the output frame, it'll also be frame 40 of the clip that's being shown. Obviously at the moment we've still got our clip running at normal speed, so that's logical. On the other hand, if I were to insert a keyframe here, we can see we can affect a speed ramp, where on frame 40, in fact, we're now showing frame 66 of the original clip. So we can see on here how the shot's faster at the beginning and slows down. Using these curves we can make a variety of motion changes. So here on frame 40 of the output we're still showing frame 66 of the original clip, but then actually by frame 80 we're showing frame 23, so this would actually make the shot go forwards and then backwards again. Sometimes we're faced with a challenge of matching a speed ramp that's been done on a different editing system and we don't have the details of what the parameters were to make that speed change. In this case we can use the time graph to build a speed ramp that matches the one supplied. So here I have a clip that has a speed ramp already in it and I don't know the parameters of that change. So I'm just going to cut it, place it on top and line it up with the source material, which is running at full length and at 100% speed, and then use the nonlinear mix, which is naturally a half mix. And then what I would do is adjust the clip until I know that I've got my first and last frames matching. So that's the first frame. And there's the last frame matched. So I now know that the target shot uses all of those frames. So I'll group them and time warp them. So I've now done a linear time warp from start to finish. If I double click here, if we drag through, then what we can see is that my time warp, my shot starts in the right place, it goes wrong in the middle, and it ends in the right place. And it's gone wrong in the middle because the target shot has speed ramping on it, whereas mine is a linear time warp, as we can see here. So what I'd simply do is find various points in the curve, for example here, roughly halfway along the clip, and adjust the frame at that particular point until we get a match, and then keep doing this at various points where the difference seems to be at the most. So you can see step by step and quite quickly I'm building a speed curve that's matching whatever was done perhaps by the original editor. There we go, it's quite close. Just clearing away that curve. So I sped the shot up by slightly more than double. So we can look at that final parameter, width. What width does is it gives us a mix between multiple frames. So it's a method of smoothing out a classic slow motion, because otherwise it's simply dropping frames or duplicating frames. We can also use it for effect. As you can see, the higher number I put in here, the more frames I use to mix together. If I was just seeking to smooth out a slow motion, I probably wouldn't go much more than 100. But on the other hand, I might want a ghostly or streaky effect, in which case then we can go up a lot higher. Let's have a look at the more advanced time warp. So this one uses optical flow technology. So in fact, let's firstly take a reference from the classic way of doing things. So group and time warp, and then under parameters I'll delete the time curve, because instead I'll set my speed to 20%. And of course, as we would expect, if I play this shot, we can see the stepping, because each frame is effectively held for 5 frames in order to affect the slow motion. Let's compare that with doing the same thing with the advanced optical flow time warp. So FX, and under image time warp, a similar double click, delete time, and under time let's put in 20 again. Now we can see how smooth our time warp is. The reason being, Mistika's working out what has changed between two frames and creating brand new frames in between those frames with proportional movement. So for example, if we zoom in and jog frame by frame, we can see every frame is different. Actually, this is one of the effects that really shows Mistika's true speed. Other systems might be able to do something like this using a plugin and some rendering time, but actually Mistika can do this in real time up to 2K. The advanced time warp still has the ability of using time, and speed. So if you want to use speed, just make sure there's nothing in the time parameter. Otherwise, we can use a time parameter to create time warps and speed ramps, just as we did before. As we saw, these parameters are common with the other time warp. In fact, they're also interchangeable. So if you were to build a time warp in the classic time warp effect and then feel that you wanted to move to the advanced optical flow version, you could simply copy these parameters, copy the whole curve from one to the other, and it would work. Under the optical flow tab, we have some controls to fine-tune the optical flow process. It's always possible with an optical flow style process that we'll see artifacts on the screen. The reason being that obviously in order for Mistika to be able to work out movement between frames, it needs to be able to see where objects have come from and where they're going to. So where we have occlusion, for example, two people crossing over each other, then portions of the person behind disappear and reappear as they go behind the person in front. And in those areas it can be challenging for an algorithm like this to work out what has gone where. So the settings here allow us to do some fine adjustments. It's worth reading the manual for a proper description, but minimum level changes the resolution of the calculation. So this is a dividing number, so the higher the number, the lower the resolution. So for example, that would halve the resolution of the calculation, which would speed up the calculation but reduce its resolution. Levels and iterations refine the result of the optical flow process. Smoothness is a value to control crossing vectors. The lower the smoothness value, the more the resulting pictures relate directly to the movement vectors. The higher the value, the less so. So where you see artifacts, increasing smoothness is likely to reduce the artifacts, but arguably also reduce the effectiveness of the optical flow process on other parts of the frame. In some situations where artifacts can't be removed, one solution is to have a couple of different time warp functions using different levels of refinement of these values for different parts of the frame. Under display, the natural output is warp, which is basically the output of optical flow. If we were to switch to mixed frames, this would be acting more like a classic time warp with the width setting higher. So the time warp would be accomplished by mixing frames together rather than interpolating between frames. Vectors are quite interesting in that it shows us the workings of the effect, and vector scale changes the size of those vectors so that we can see them more clearly. For example, if I zoom into the area around the mouth and increase the vertical scale, we can see the motion that Mistika is detecting in the frame. Similarly, slopes gives us a color for the different directions and different velocities. We can use those two tools to help us see areas that are liable to artifacts and to fine-tune to get rid of them. In fact, we can also use this potentially to key on certain colors in order to get alpha channels derived by directional velocity. The deinterlace mode is only relevant if you're starting with interlaced material and rendering an interlaced result. The deinterlaced values can be default or adaptive. Default uses a standard interpolation between lines, whereas adaptive uses a diagonal interpolation, which on certain media can give a better result. One thing to note about how we are visually seeing a time warp on the time space is that we would normally expect that we would be seeing this clip from this frame to this frame. In fact, of course, if the time warp is slowing things down, it may well be we'll only get as far as this frame on the source material because it would have stretched it out to be the full length of this clip. Likewise, if the time warp was speeding the shot up, it might well be that we need to have more heads and tails. If this shot is effectively being played quickly, it'll reach the end of the clip before this will. So those are the two methods of affecting a speed change to a clip within Mistika.